Today in class, we're going to review some of the forms of the equation of the quadratic that we've looked at earlier this chapter. And we're going to do that by looking at something called the Snowplow Problem. So this is section 6.6 in our chapter, and this link will be on Google Classroom, and we're going to work through this mostly together in class. So here's the problem. You're thinking about starting your own snowplowing business. How much do you think someone would be willing to pay to have their driveway plowed? If you were the one plowing the driveway, how much would you want to charge each person to plow the driveway? So you can go ahead and answer that. You are thinking about starting your own snowplowing business. Can you list at least 3 things you need to consider when you start a business? So they could be things like cost of supplies, again, like how much you're going to charge, how much time you have, anything that you need to think about when you start a business, how much money you have to start with, and so on. All right, so step 3, let's compare the price that is charged to plow a driveway and the revenue. So the revenue is the profit that you make when you have a business. So this says, how does the price you charge to plow a driveway affect the revenue that you make? So if you're going to charge not that much, what do you think is going to happen? If you charge too much, what do you think will happen? Oh, that asks it right there. What happens if your price is too high? What happens if your price is too low? So go ahead and answer that. And then what mathematical function, absolute value, exponential, linear, quadratic, or other, would model the situation? Hint, think about what unit we're in. And then why do you think that? So go ahead and answer those questions. Sketch what you think the price versus the revenue would look like. So again, this is no right or wrong answer. I just want to see what you can come up with. What do you think this graph would look like? Again, what you charge is on the bottom. How much profit you make is on the side. What will that graph look like? What do you think? Your business breaks even if you charge $5 or $60. What does it mean for a business to break even? And what that means is that they're not making any money, but they're not losing any money. So not making or losing any money. Why are the 2 prices that you could charge to make the business, why are there 2 prices that you could charge to make the business break even? So again, I want to see what you can come up with. Why are there 2 numbers here for what we could charge to break even? On the graph of your company's revenue, where would the break even values be located? So again, what does that look like on your graph? And then we'll take a look at what it looks like for this function. Okay, so here, if you came up with this graph, this is the graph. It was quadratic. We are in the quadratics unit after all. And again, we talked about breaking even at $5. So that's down here in blue right here, the $5, or at $60, you're breaking even, which means you're making no profit. And as we go up, we can see we're making more and more profit the higher we go, and then we'll make less and less the lower that we go. So it says, using your break-even points, write an equation for this graph. Okay, let's try writing the equation for this graph. We know that the A value is -1. And we know the zeros of the graph, the x-intercepts, and one is at 5, so I'm going to write x minus 5, and the other is at 60. And again, if you remember from when we looked at x-intercepts, if you know the x-intercepts or the roots of the graph, when you write the factored form, it's the opposite of that, because then when we use zero product property, we would be able to get the zeros of our graph. So there's the equation for that. You could submit it. How much should I charge to make the most revenue? Where on the graph is the most revenue located? Okay, so highest profit, revenue is profit. And if we take a look, it's a little bit over, okay, so here's 700, 750. It's a little bit over $750 profit, but let's see how much we have to charge for that. And we can see that it's going to be a little bit more than $30 a driveway. So let's see, is this going up by 2s? 32, 4, 6. No, it's not going up by 2s. Oh, it's going up by 25. So this would be like 32.5. It's going up by 250. This would be $35, and this would be $37.50. So it looks like $32.50 is pretty close. And this point is called the vertex right there. Okay, so so this would be the vertex. using your break-even points of 5 and 60, how can you determine the price? Okay, well, let's take a look at our graph. Here's the 5 and here's the 60, and we know it's going to be in the middle of those numbers. So what we're doing there is we can average the numbers to find the middle. So let's do that. We can average them. I wonder if we can use our calculator tool. Does this work? So we have our 5 plus our 60, and then divide the whole thing. Ooh, I have to use parentheses. Ooh, here's our calculator. No, I have to use parentheses though. Okay, so we can do, let's find the middle of those two numbers. 5 plus 60, divide by 2. Does it not give me the answer? Does not. Okay, 65 divided by 2, what is that? Okay, so there it is, $32.50. That would be the price in the middle of 5 and 60. So $32.50 would be what we need to charge to get a maximum revenue of a little bit over $7.50. That's a lot of money. Okay. What is the average of the break-even values? Okay, so we did the average. We said, someone's okay, so we said that the average of those is $32.50. Using your equation from slide 6 and the average price found above, can you calculate the maximum revenue? Okay, so we have to go back to slide 6. Okay, here's my slide. I'm going to write this down because I need to show my work here. So I'll write down my equation first. Minus 5, x minus 60, but x equals 32.50. Okay, so here's my work, here's my equation, and here's what x should equal. So let's figure out the cost. I mean, how much profit are we going to make? So y is the profit. So -1 times 32.50 minus 5 times 32.50 minus 60. And let's get that revenue. I'm not doing that in my head. I will type it in. So -1, 32.50 minus 5 in the first parentheses, and 32.50 minus 60 in my other parentheses. All right, so I said it's a little bit over $750, and we can see it's $6.25 over $750. So that is our profit that we're going to make if we were to charge the optimal price of $32.50 per driveway. That is expensive. I would not pay someone. I would just probably shovel it myself. All right, so there it is, $756.25 by plugging in $32.50 into that equation with the x-intercepts. So if we type that in, and it was, I forgot already, $756.25. Okay, so you can submit and explain. Label the point for the best price and maximum revenue on the graph. And what is that point called? It is the vertex. It is right here. And label it. So that was at, see if I can write this in. I probably could use the text tool. So it'd be $32.50 for maximum revenue of $756.25. Can I just type that in? What happens if I, oh, there we go, $756.25. That's way easier. Can I put a $sign in front of it? Yes, I can. Okay, so that was so much easier. Okay. All right, so there it is. There's the revenue, $32.50. I forgot my $sign. And then, sorry, that's not the revenue. That is the price to be charged, and then the revenue, $756.25. Using your best price and maximum revenue point, write an equation for the graph. The A value. Oh, this is the vertex, and we shifted it. Okay, so now let's think back to the vertex form, shifting it to the right 32.50. Okay, so we have y equals, and it's -1 because it's a frowny face, it's upside down. But then we know that we shifted at 32.50, so x minus 32.50. And then if you remember, it's a quadratic, so we got to square that. And then it goes up 756.25, so plus 756.25. So that's vertex form, right? If you have left or right, it's the opposite of that, and that goes with your squared. And then up or down, it's how much you move up or down. So there it is, and you can explain this as vertex form. So if we know the vertex, we actually can use that to write the equation. What does the y-intercept represent for our business? Okay, ooh, our y-intercept's like way down here. Can I move the graph? No, I can't. Okay, so the y-intercept is going to be like way down here. We can't even see it. Can I? Oh, I can move it down. Okay, so there it is. It's at negative, what is this going up by? Again, by 25s here. So negative 250, about negative $250. And what does it represent? So it's the amount that it costs us before we start charging customers. And why is it negative? And that's probably the cost of a snowplow and gas, right? You need to buy all that stuff before you can start plowing driveways. Unless you're doing it with shovels, which doesn't make any sense, but then you could be spending that money on shovels. So this would be your overhead cost is what it's called. So the amount, the startup cost to your business, the overhead. So that's why it's negative. Earlier, you should have modeled your business's revenue with this equation. So this was slide 6. Based on the price charged, find f of 0. So this is saying if you charge $0, how much would you make? So you charge $0, or you shovel the driveway for free. How much does it cost you? And if we're mathematically going to do that, here's what it looks like. So it's the same equation. Let me just erase this. All right, so they want f of 0. So it just means plug in a 0 here and a 0 here. And this is negative 1 times negative 5 times negative 60. Okay, so let's multiply that out. Negative 1. Ooh. Is that the right equation? We better double check. Okay, it is. So negative 1 times negative 5 times negative 60. Whoopsies. Okay, negative 300. Did I count? I must have counted that wrong then. This is saying negative 300 for our starting value. So let me go back to the graph here. Which one was I on? Nope. I was way ahead here, wasn't I? Okay, so the y-intercept, and I moved it down. Okay. Oh, yes. Okay, so, yeah, I just counted wrong. So this should be a negative 300 because it's going up by 50s, not by 25, silly. So negative 300 is the starting value. So y-intercept, overhead costs, or starting costs. You have to buy the plow. Okay, and we can see that it's not negative 250, which I said. It's actually negative 300 is where we're starting because it goes by 50s, not by 25s. Okay, so f of 0 equals negative 300, and that just means this is how much profit we make if we don't charge to plow. All right, using the equation what's the y-intercept? Okay, so again, let's just plug in f of 0. Let me write this down. So this is vertex form, so we did intercept form up here. Here's vertex form, so f of 0 equals negative 0 minus 32.5 squared plus 756.25. Okay, so here's what they want us to do. And I just plugged in a 0 for x, and let me type that into my calculator. Negative 0 minus 32.5. We'll square that. And then it was plus 756.25. Oh, and look, it gives us the same number because it's the same equation. It's just a different form. It's vertex form versus intercept form. So we get the same thing. We still get negative 300. F of 0 is still negative 300. Because it's the same equation. Well, it's not the same form, right? It's the same function, but one's in intercept form and one is in vertex form. But it's the same numbers. All right, explain how your business could earn $500. If that is not possible, explain why. Okay, well, let's see. Does the revenue ever equal 500? And it does. It equals it twice, right? So the first dot I can't draw anymore is right here. and the second if we charge this amount here. So the first amount that we could charge to make 500 looks like, a little bit under $20. And then the second amount looks like a little bit before $50. So we can earn 500. Yes, we can. We can earn it if we charge the two amounts. Explain how your business could earn $1,000. Okay, if you notice, the highest revenue was that $756. So we can't, using this model, ever earn $1,000 if we buy that snowplow. Our graph just doesn't go high enough. So again, it can earn $500 if we charge. Okay, so we can kind of estimate this. This would be, it's going up by 0.2, so $15. I don't know, is that like 17, maybe like $18 over here? And then this is 50. So like $48 maybe. So again, if I were to draw this line across, there's two spots where it gives you what you could charge to make $500, but not $1,000. Okay, so that's it. We took a look at going over the differences between intercept form, where we look at the zeros. So just to review, that was like over here. So if we know the zeros of the graph, we can write the factored form. If we know the vertex of the graph, we can figure out maximum profit, and we can write the equation in vertex form as well. And just knowing that those two forms look different, but that it gives us the same graph, actually. So your assignment will be posted on Google Classroom, where you're going to practice these ideas. So you can let me know if you have any questions, but get that assignment done for next class period.